Welcome back to GCSE Minecraft and Chill. I hope you're having a good day so far, and if you've already watched today's maths or physics videos, you already know the drill. We are starting at the beginning today with the topics. My hope is that you'll gain an understanding of the bigger picture, some of the context for why you have to learn what you have to learn as a foundation for advancing your study of chemistry and, honestly, science in general, and revise some of the core principles of atomic structure to help you absorb the information in a different way to hopefully boost your skill in an exam. So, grab a drink, get your revision notes, or do whatever else you're going to do while I chatter away and entertain myself and maybe you with some Minecraft. And I'm still working on this building, just figuring this roof out. But if you already know it or recognize it, please comment what you think it is, because I'm really interested if anyone can tell what it actually is. So I'm going to hop about and work on this while I talk about one of my favourite topics, alchemy. Well, I'm not actually going to go fully down that rabbit hole because it is a huge topic, but I am going to talk a little bit about the history of chemistry, metallurgy, and how that connects to modern chemistry and the stuff that you have to know in your exams. And the reason I say that is because what interested me in chemistry or in science at all when I was a kid, and what gave me a really good understanding of the context behind what I was learning at school, that then allowed me to find patterns in what we were studying. And I managed to do that quite quickly and easily, and so I performed extremely well in my chemistry exams. And that consistently strong performance carried on all the way through to university until I got really ill, and then everything went wrong, but that's a story for another time. Until that point, chemistry was consistently my best scoring subject. And what started all of that is the fact that I, like Andrea from Andrea's Fashion Galaxy, please check her out, like she says, we are shameless magpies, drawn to all things shiny, glittery, sparkly, to decorate our nests. And I was, and I still am now, an avid crystal collector. I love gemstones, rocks, glittery things from the earth of all kinds. Love them. My pens are glittery. My makeup, when I wear it, is glittery. And if I'm wearing anything other than black, it's probably going to be something very bright, shiny, or sparkly. And although there were sort of other pieces of the story along the way that led to me doing a geoscience degree, it was really this interest in crystals that really started it all off. And I didn't start to understand rocks properly until I got to university, but that's also another video where I will talk about rocks if you're interested. What's important here is that this interest in crystals, in what magical properties natural materials, minerals, and elements had that gave them this sort of really gorgeous crystalline form and sparkliness, and also, like every other cursed child, reference not intended, from my millennial generation, we all read and enjoyed that TERF's book series that involved a search for a certain philosopher's stone. And that is what piqued my interest in alchemy. And I sustained that interest. I started reading and I learned about astrology, Sumeria and Mesopotamia, Egypt, medieval Arabian scholars, ancient China and indigenous American healers, herbalists, wise women. I learned about paganism and the Wheel of the Year. I learned about magical practices all over the world, natural magic. And eventually that led me to the Greco-Roman cults that worshipped goddesses, Hecate among them, and other deities, but Hecate is the one that stuck with me, thanks to Buffy the Vampire Slayer in part. But the metaphor and symbology used within alchemy for the philosophical and spiritual quest for enlightenment, self-healing, and wholeness within the universe, and how that pertained to some specific ritual processes in purifying minerals and metals, that was like, I was like, what? My mind was blown. So back to the point, thank goodness. Like I said, this is a really big topic for me, so I'm gonna try to keep it reined in, or this video will be hours long. And I'm like touching really, really briefly on a lot of very deep and context heavy stuff. So anyway, suddenly, before I knew it, in my own time as a hobby, like I said, I was reading about people from hundreds and hundreds of years ago, if not thousands, who are using distillation, evaporation, crystallization, and filtration, boiling and smelting and grinding stuff to combine powders and liquids, and purifying certain rocks and metals to obtain different kinds of metals. And and all of that. And I could, in the diagrams, in the old pictures, if you've ever seen any of them, you can recognize the equipment that they're using and the processes that are being described in these ancient documents. They are literally what you learn in school today, in the labs, in your practical lessons. And that just made it so much more interesting to me, and I needed to know more about it. And I relished every opportunity that we got the Bunsen burner out and the measuring cylinders and the conical flasks and doing all sorts. Mostly setting fire to metal powders was really fun. I enjoyed that, seeing all the different coloured fire. And that's cool, right? Because these techniques of separating mixtures and materials, check out my shorts this week. I have one about which techniques are needed for what thing. These processes were used to create tinctures and healing oils and obtaining chemical resources for medicines and metals for tools that we need today, just like they were hundreds of years ago. The principles are sound. We have not needed to change these techniques that much in, over 1,000 years. That's really impressive, considering all of the technological advancement that's happened in the last 1,000 years. So smelting, purifying liquids and powders, investigating the material properties of the natural world and the resources around us is not new for humanity. And while I am absolutely no archaeologist or anthropologist, I will leave that to Mini Minuteman. Check him out. Apparently this is the podcasty episode where I'm just going to be linking you to all sorts of other YouTubers that I watch. But anyway, go watch him if you're interested in archaeology. What I'm interested in is the fact that new evidence is being found all the time that is pushing the dates that humans are thought to have been using copper, for example, or creating metallic tools or like more complicated metallurgy. It's a really, really ancient thing that humans have been doing. Currently, we have found evidence that humans were using gold as long as about 42,000 years ago, and the oldest examples of copper being used have been found in Iraq from around 10,700 years ago. And that's incredible. That's over, imagine all of the advancements that have happened in the last 1,000 years of humanity. Imagine 10 and a half, or just over 10,500 years of smelting metal, the tools, jewelry, money, weapons, and we've been doing it for that long. And I'm now doing a PhD looking at how depleted uranium metal corrodes in different environmental and storage conditions. So we are still learning about this stuff, and that is bonkers, and I love it. I love metallurgy, and the history around it is so incredibly rich and tells such a fundamental story of humanity. Side note, that's kind of why I like Minecraft. I like the the natural resources and tools and building part of it, but anyway, I digress. So over all of this time, we've been categorizing different materials based on their properties, their uses for us, and the processes that are required to concentrate it for those specific uses. And recording that knowledge was important for beginning a more rigorous and a more intergenerationally transferable knowledge, right? So a lot of very, very, very valuable human knowledge has been passed in oral traditions through music and stories. And what happened with the development of modern science as we know it now is that ancient scholars, particularly Indian and Islamic and Egyptian scholars, they were so brilliant and fantastic because they were doing consistent, repeatable experiments. They were writing them down and they were exchanging this knowledge amongst other early ancient scientists and scholars around the world freely. And these processes are what paved the way for the advanced, metallurgy and science that we do in chemistry today, in chemistry and physics. The boundaries between the subjects are obviously quite fluid and not as rigid as one might think. But anyway, so that's what kind of brought us very, very broadly and shallowly to modern chemistry. And one of the first things you learn in chemistry, the first topic, is you start off with the periodic table of the elements, and you start off about learning about atoms. And the story, I feel like the story of chemistry is not really given enough credit, because that's not where the story started. We've only known about atoms and atomic structure for, well, the last 100-ish years, right? Before that, the periodic table of elements was arranged in terms of weight, and this, at the time, was a very sensible and logical way of categorizing the different elements. Because remember, the thing that we were primarily interested in for chemistry was developing the metals particularly, but all the elements, into tools, into soap, processing soap or beer or wine or medicine. The weight wasn't as important as the unique properties of each of the elements and the behaviors that they exhibited. And that's still what modern chemistry is. It's understanding the behavior of the elements according to the model that we have that utilizes our understanding of electrons to explain the phenomena and the properties and the behavior that we see. So while weight does give us some critical insight into the underlying structures of every individual element, it was the properties being grouped together that gave away how important the mass making up the nucleus and the behavior being explained by the electrons surrounding the nucleus are. And that's the brilliance of Mendeleev, that he left gaps in this more modern version of the periodic table, knowing that the weights and the properties were two separate but important connected features, and that there was this bigger picture, and that neither weight nor the properties alone were enough to sort of explain everything that we see. So to really understand this, think about why you learn about the differences between the three extreme groups in the periodic table. So groups 1, 7, and 8, or 0, whichever you want to call it. Considering why the properties in these groups are different to each other, regardless of what the relative atomic masses or weights are, teaches you to understand these foundational principles of chemistry. It teaches you to look at the periodic table and see not just a chaotic cluster of boxes arranged randomly on a piece of paper, but it's a map to understand natural resources. And that map has been built by considering the different repeated patterns in behavior, and those properties and behaviors that we've observed because of what we're actually using elements for. But why? So thinking that's sort of how it came to be. Now think about why, from a scientific perspective, why is matter, why are the elements what they are? Why do we have 3 protons and electrons in lithium? Why do we have 20 in calcium and about 35 in chlorine? Why do those specific numbers cause such a radical difference in their properties? Why do we label them as different things? And how do we know that that forms predictable compounds? And these are all the important questions that you'll be considering and studying if you want to master the discipline of chemistry and know how to do things like take a random rock and turn it into a vital ingredient in a life-saving medicine when you combine it with the right distilled oil from the right plant, right? Or how to mine and extract the correct ore and make it the perfect tool that makes the comfiest and coziest wooden chair. And how do we do that in a way that doesn't completely destroy the environment, you know? That it's this like wild thing to me, a wild property of nature, that the elements are just a sequence of counting up protons and electrons in various balls of mass, and they've all got really weird names, and they look like just dull grey blobs, most of them in their elemental form. But put them in through a few chemical reactions, and you get something as perfect and beautiful as an amethyst crystal. And what, like, isn't that mind-blowing to you? We're just counting really from 1 up to about 103 or a little bit more, and we get these distinct clusters and properties because of the nature of electron orbitals, or the electron shells, that group these elements together. And the names are just slightly more convenient labels than just referring to each element as a number. So think about that, right? That it's about the electron orbitals, it's about the shells. So we then might to start consider the interesting numbers. Why are 2s and 8s the important natural numbers from an atomic perspective? If you ever get to a level where you start to study quantum chemistry, you'll learn why that's the case. It's about stability, squares and circles, quantum spin, balancing each other out, and immediately we're back to talking about maths and geometry and alchemy, and that's just like straight up magic to me. But regardless, if you can see how every property of every material is arising because of the number of protons and electrons, which are always going to be the same in order to conserve the electrical charge around the nucleus and keep an atom balanced, then you'll see that each individual element is just a labeled form of counting protons and electrons. And like, it doesn't sound like I'm saying anything profound, but if you really understand that, you understand chemistry. And I say that and I truly believe it, because no matter how advanced the chemistry that you're studying will get, it's always going to come down to conserving energy, charge or mass, and abiding by the rules of electron orbitals and stability. And that's why a lot of the other later topics in chemistry, you have to balance reactions, you have to predict the compounds or products that are going to form when you mix certain reactants together. You have to know the patterns and properties of certain groups, or what happens when certain groups mixed together. They have characteristic reactions, like acids and bases are always going to make a salt and water, but equally you need to know what happens when group 7 halogens react with alkali metals from groups 1 and 2, because they also have characteristic reactions. So if you understand their position in the periodic table and what that means, and how they're either trying to empty or fill an electron shell, and their respective reactivities based on their positions within the group, chemistry is a total piece of cake from that point forwards. Like I've said in a million of my shorts at this point, if you've seen them, the periodic table is the key to understanding this. And next week, in my GCSE Minecraft and Chill video, I'll be talking about the properties and trends. So if you found this vaguely interesting at all, you will definitely enjoy that video, so tune in next week. But I think for today, that's going to do. So thank you for watching. Whatever you do, be kind to yourself, because our words are spells. Have a lovely rest of your week. I'll see you next time. Yalla bye.